Okay, in this question, we are actually supposed to prove that the velocity of the fluid going into area V1 is actually given by this expression here. So what we need to look at is the continuity equation and also Bernoulli's equation. The continuity equation states that the rate of a volume of an incompressible liquid going through one area would be the same as the rate of the volume of the liquid going out another area. So what we have here is cross section of A1 times the velocity V1. So that gives us a velocity of, or a rate of volume going in, equals to cross section A2 times V2, and that's the rate of the volume going out area 2. So let me rearrange this because it will be easier for me to use it this way later. So A1 over A2 times V1. Okay, and then we also have Bernoulli's equation, which states that the pressure P1 in one area plus the rate of the fluid flowing in that area, and if there's any height discrepancy in that area, so all these will attribute to its pressure. So Y1 equals to the pressure in another area plus the velocity of the fluid going through that area and any differences in height of the fluid. Sorry, Y2. So in this case, the point of P1 and P2, they're on the same level. So basically these two terms will cancel each other out. The other part that we need to do is we have actually these rods here in the way that are measuring the pressure. Let's label this as H2 and let's label this as H1. So P1 would be equals to H1 rho G, while P2 will be equals to H2 rho G. Okay, so let me number the equations 1, 2, and 3. And what we do now is substitute the equations. So substitute 1 and 3 into 2. So what we have here is H1 rho G plus half rho V1 squared equals to H2 rho G plus half, so I've substitute V2 here, that becomes rho A1 over A2 V1 squared. So let me bring, before that I can actually drop rho because that's the common parameter among both sides of the equations. So let me bring V, the ones with velocity term, over to the left and the ones with the height term over to the right. So I have half V1 squared, so this would be 1 minus A1 over A2 squared equals to H2 minus H1 G. Okay, and if I try to simplify it a bit further, so I actually get V1 squared equals to 2G H2 minus H1 over 1 minus A1 over A2 squared, and that gives me V1, which is the square root of the term above, which is 2G H2 minus H1 over 1 minus A1 over A2 squared. Okay, so that's your answer.